Okay, a quick reminder about how you change a graph to be sine of 3 theta instead of just normal. The normal is to have these numbers right here, pi over 2, pi, 3 pi over 2, and 2 pi. And then we took this number right here, the b, put it into the little formula 2 pi over b, and then we knew to divide everything by 3. So we divide everything by 3 or multiply it by 1/3, which does the same thing, and got our new numbers right here. So that's a kind of problem you have to know how to do. So in this very first one on your packet, you might want to get that out too, because we'll do something together. 30A, we already have the numbers now. It's what you put in your notes there. That's the numbering for the axis. So you can just graph it like normal and then just use the new numbers that we just figured out, which ended with 2 pi over 3. It started with pi over 6. And what was next? Pi over 3, I think? 1/6 pi, 2/6 pi, 3/6 pi, and 3/6 would be 1/2 pi, so pi over 2. Uh-oh, this is cosine. It's still the same numbers and everything, but I have to erase my line and put in a cosine. Sorry. So look at the red line, not the green line. And now the only other thing is this number out in front. That's known as the, starts with an A, amplitude. And the amplitude, instead of being normal 1, it's 1/2. So instead of this being a 1, it's a 1/2 right there, and a negative 1/2. So there's the answer to that one. All right. Not the green line, the red line. Over here, cosecant. If I was ever asked to graph cosecant, I would graph something else first, sine. And once I graphed sine, then on top of its humps, I would find cosecant. And then, forgetting that? You have the quizzical look. I'm trying to figure out if you're not understanding or you're okay. No, it's your normal look. All right. Anyway, these numbers that would go along here, it's got the 3 here again. So then I can use these same exact numbers from over here. So this, and this. Those numbers can go here, like pi over 6, and there, and there, and there. Okay. But yeah, the hard part is now the negative out front makes the whole thing flip. So then I really don't want any of the stuff that I just graphed up here, because that's going to end up flipping so that I go down here instead and up there instead. So if you can focus only on the black lines, that would be the answer for that one. I know it's a bit of a pain, but yes?
Having 2 of those flips, is that a period or is it just one?
That is a good question. One of each makes a full period. And does the direction say to do 2 periods? If it says to do 2 periods, then you'd have to do another one. Now, reality tells me that on the test, it's a multiple choice test. You aren't going to be actually hand graphing these things. You're going to have to be able to pick them up out of a lineup, right? You're going to be looking at A, B, C, and D and figure out which one's right. You know what I mean? All right. So this whole, and I bet you that they would do that. Like one of the right answers is the right answer, except with only 1 period graphed, and the other one would be the exact same thing with 2 periods graphed. So if I want to get another period in here, I would just have to say, okay, my next one's going to be an up one, and it would be like this, and then my last one will be a down one, and it would be like that. So now I got 2 ups and 2 downs. That would be 2 periods. Tangent. The normal period for tangent is 1 pi, but that does not mean this is at 1 pi. That's at a 1/2 pi, right? And then it goes a 1/2 pi this way. And so that's normal tangent. The total length there is 1 pi. So 1 period is equal to 1 pi, not 2 pi. Okay? All right. So I think you're going to be all right with a lot of this graphing stuff. If you remember your basics of it, it's really not too bad. I'll look at one more with you here. Look at I. I as an ignoramus. So I think there's a 4 on the bottom of the fraction. If you could verify that, mine's cut off. Is it? Okay. Then, if I was going to graph this one, first of all, I graph normal sine. Normal sine. Then I put on the numbers for normal sine. Pi over 2. Pi. 3 pi over 2. And 2 pi. And then I would change all of them because I got to go period equals 2 pi over b, and b is 1/4. And that means effectively dividing by 1/4 means times the 2 pi by 4. So that's going to be 8 pi. So if I'm going to change this to 8 pi, I'm timesing it by 4. This will become 4 pi. I times this one by 4, and I times that one by 4. So then my new numbers would be 4 pi over 2, which would be 2 pi, 4 pi, 6 pi, and 8 pi. And then the other thing is there's a 4 in front, which means that this is no longer a 1 and a negative 1. It's a 4 and a negative 4. I think those will be easy for you. So let's move on to some stuff that'll be more of a challenge. Okay. Look at tangent number S. Letter S. Sorry. S is in Sam. So Sam, what's normal tangent look like? Can't find S. That's kind of sad.
That looks like normal. It's pi over 2, negative pi over 2.
All right. Negative pi over 2 and pi over 2. Very good. And this thing, though, what is this guy? Don't have to factor it because there's nothing in front of the x. But what does that minus mean to you? Right. Pi over 4. All right, that's 1/4 of a pi. Well, a half of a pi, would you agree that this is a half of a pi? So if I'm supposed to move it 1/4 of a pi, do you get that that would be half that much? So I got to move it over that far. Which way? Got a minus there. To the right. So I got to move it over that to the right that far. So I'm going to redraw mine because I can do this with a smart board. I'm going to draw it again, and then I'm just going to grab it and move it over. I know. That far. And yes, I'd have to move my asymptotes too. So if outside the classroom you ever told me to move my asymptote, I'd be like, you're in trouble. But in here, yes, I just need to move my asymptotes over. All right. Okay. A sinusoid with amplitude 4 has a minimum value of 5. Find its maximum. Okay. So if I know its amplitude is 4, that means that when it goes up and down like this, the amplitude is from here to here, right? So it has an amplitude of 4. So if it's minimum, the lowest it ever goes is 5. Then what's the highest it ever goes? And it's not 9. You get what I'm saying? Well, I just got to go up 4 just to get to the midpoint line, and then up another 4 to get all the way up to the top, which would be what? 8 and 5 makes 13. Very good. Isn't it 4 plus 4 makes 8 plus 5? I think it's 8 plus 5, which makes 13. I'm saying the minimum was 5. This is at 5. Then I have to go up to there. Where would that be? And I have to go up 8, right? So 5 plus the 8 makes 13. Okay. I maybe you were adding these two or something first. Okay. Anyway, moving on. That was a pretty easy one. This one. This one's going to require us to remember what logs graph looks like. lnx. And I bet you some of you have forgotten. So I'm going to give you a brief little reminder. Maybe off on the side in your packet, you can draw yourself the mother function for log. And it looks something like this. It's sort of like a tree that was growing up straight but then got blown over in a giant tornado. I was reading about a lady in Joplin, Missouri, who was one of the people who lived through this whole thing. And she probably felt pretty smart. She had bought a Kevlar chamber that you can hide in case of a tornado. and you bolt it to your garage floor because that's one of the most solid things that there is because it's all concrete. And like even when houses get ripped away, their garage floor is usually still there. And she bolted it, had it bolted to her garage floor. She heard the sirens and everything. She believed that it was actually coming, and so she grabbed her cat, ran, jumped in there, and her whole house like collapsed around. But she stayed in this little chamber, safe and sound. She could see out of it too. Wouldn't that be kind of crazy? Nope. Their what? The football team was. Okay, here we go. So log. Here's the log graph. So when they take the log graph and they do +3 to it, where does it go? Up 3. Up 1, 2, 3. Just like that. Okay. Now, if I asked me to take that and like flip it or whatever, you know what the parent one looks like. So that's log. How about the one that goes like this? What's that one? Exponential, which is y equals what? Whereas this one was y equals ln x. This other one would be y equals what? E to the x is a classic. Yep. And you could even be 2 to the x or 3 to the x. But e to the x is kind of the natural inverse of that one. Remember how inverses are a flip over that line? A lot of things to remember in here. Okay, so go back to this, and this is that base graph I just showed you 2 seconds ago. It looks kind of like that, and the things shifted up, and then they asked the domain and range. Well, the domain and range are basically asking how far can it go this way for domain, and how far can it go this way for range. Okay, well, let's talk domain first. Domain. How far can it go the domain this way? How far can it go that way? What's the smallest it can ever be? This line right here, that won't ever go past 0, will it? It's going to get closer and closer to 0, but never touch it. So 0 parentheses to infinity, and also a parentheses. The range is on this way. So the smallest it could ever be, negative infinity, all the way up to, as it rises, it looks like this has a cap on it, but it doesn't. It keeps rising forever, positive infinity. Okay, there's how you write your domains and ranges in interval notation. Does it ring a bell? Remember how to do that? Yes?
Would you say it's just easier if you just graph these when you got the test?
It is allowed, and the graphing calculator is, yep, that's not a bad idea. Yep. So if you had a graphing calculator, you just type in the graph quick, you're still going to have to know what domain and range are to be able to have a chance to answer the question. All right. How about inverse sine? That one might not be so easy. All right. I'm going to remind you, inverse sine is, if I want to know the domain and range of inverse sine, what would it be smart to figure out first? It's the domain and range of sine. All right, so here's sine. And remember that when we're doing these kind, we don't graph all of sine. You remember how we only graphed this part of sine? Because it's the only part that you could flip over this line here to have an inverse. Remember that? All right, so we said that domain and range for sine were from negative pi over 2 to, what's that spot? Pi over 2. And that's the domain of sine. So what's that for inverse sine? It's the range of inverse sine. The range of inverse sine would be from negative pi over 2 to pi over 2. And if this is the range from, well, I guess it's actually there, from 1 to negative 1, if that's the range of regular sine, then it's what? It's the domain of inverse sine. So the domain of inverse sine would be from negative 1 to 1. Okay, I think you get the idea on those. All right. If k is not equal to 0, what's the range of the function that? Well, first of all, I would say if this had just been plain old cosecant, I would graph plain old cosecant. Cosecant rides on top of sine. So there's sine. So there's cosecant. So there is, what is the range of those red little loopy things? Well, it's from negative infinity all the way up to negative 1. Can be that. union with 1 to infinity. That's normal range for cosecant. So if it's got a k here, it's just going to make it, that's supposed to be an x there, sorry. This k right here is going to make it stretch, and then the 1 won't be a 1 anymore. It'll be a k. You learned range, and you learned that if there's a number in front, that's the amplitude, which makes this number go up or down. You could have put that together, and I just put it together for you in case you needed it. Okay, next thing, find the values of all 6 trigonometric functions. So you want sine of theta, cosine of theta, etc. Well, one of these is really easy. Tangent, I already got both numbers for. I could do tangent of theta is 7/11ths right off the bat. And cotangent is also easy. That's 11/7ths. You get that? How about sine and cosine? I need the hypotenuse. So I just got to use these two to find the hypotenuse. And from there, it'll be easy. I'll be off and running. I can do sine, cosine, tangent. Oh, the evil twins are just flipping them over. Those will be easy. Okay. Let's do 37 next. Assume that theta is an acute angle in a right triangle satisfying the given conditions. Evaluate the 6, mine's cut off, the 6 trigonometric functions. All right, so basically, it's the same thing except they didn't give me a picture. They just gave me a cosine of theta is 5/11. So I know theta is like this, and cosine is adjacent over hypotenuse, so the adjacent side is 5, hypotenuse is 11. I figure out that side, and then I can do the 6 functions of that. You know what I mean? Once I figure out this side right here using a squared plus b squared equals c squared, if I wanted sine, I'm going to call this for n for nasty number I have to figure out. And then I want the sine of this, it would be opposite over hypotenuse, n over 11. So I figure out what the nasty number is, and then that's how to get the sine of it. Etc. There's 6 functions like that. Those, I think, should be fairly easy. All right, we're almost to the part where I'm going to stop, but we're not quite there. Cosine of 120 degrees. Yeah, you got a calculator. Just type in cosine of 120. Do it right now. See what you get. I bet you you'll get 2 different answers. Why would kids get 2 different answers then? Aha. So be careful. If one kid has in radian mode, they will get the answer wrong, and I bet you that that's one of the answer things on ABCD. We try to make the answers on ABCDs that aren't the right answer. We try to make them the common mistake answers. Okay, so we would probably have that in there. All right, so if you got it, your calculator in degree mode, 100 cosine of 120 is what? -1/2. All right, done. That's it. Now, I know some of you were thinking that this is like the other ones where it has 2 answers. That's where you're trying to figure out the degrees. Like if this said cosine of theta equals 1/2, then there could be more than one possible answer. You know what I mean? There could be more than one thing because you do the all students take calc thing and you find there's 2 different answers. But cosine of 120's just got 1 answer. All right. What if it's like this? I would put my calculator into radian mode, and then I would put in 7 times pi, divide by 3 in a parenthesis, and I'd just do it that way if I was in radian mode. Otherwise, if you really must use degrees, change this to degrees first by multiplying by some fraction involving pi and 180. If I want to turn it into degrees, I'd want the degrees on top. And then I could cross multiply, and I could cancel the pi's, and then I'd say 3 goes in here once, and in here 60, and then I'd have 60 times 7 is 420 degrees. So if you really want to, you could do it that way, and then you could do cosine of 420. But you'll have a calculator, so if you want to just do it with a calculator, that's the easy way. All right, and this one, though, they try to set up specifically so you couldn't just type it in the calculator. You got to figure out what's going on. Evaluate the 6 trig functions of this. Well, remember that if when we first were doing this, and we did this was 30 degrees, and we figured out the answer for it, and then I said you could also go over here and do the same thing. Do you remember that? That if this was 30, the answer for this, 150 degrees, would be the same exact thing as 30 was. Know what I'm talking about? All students take calc. Sine is positive both here and here. So the sine of 30 and the sine of 150 would give you the exact same answer. But we can't actually draw a triangle with a 150 degree angle in it, right? So instead we use this triangle right here. It's a reference triangle. Same thing. That's some monster angle that I don't know. But it's going to cause me to use this triangle right here and then figure out this. And once I know this, I can figure out how big that was. All right. So I'm told 3 comma negative 5. That means the x is 3, the y is negative 5. See where this is going? And I can figure out the next one right here by using a squared plus b squared equals c squared. All right. Okay, and I am done for today. I will teach you more stuff about this tomorrow. Mr.